Candidates were required to Roman 1 determine the bond equivalent yield of each instrument, assuming a par value of 100 shillings. Then in Roman 2, candidates were to advise on the best bond to invest in. The best bond to invest in. Determine the bond equivalent yield. Now, candidates, a bond equivalent yield, the BEY, is a metric that is used to compare the annual returns of fixed income investments, especially those with interest payments made more frequently than annually. It could be semi-annually, it could be quarterly, it could be monthly, and so on. And it essentially expresses the interest rates on the investments as an annual percentage yield, So candidates, a bond yield equivalent is a metric that is used to compare the annual returns of fixed income securities or investments, especially those with interest that is earned or made more frequently than annually. Then in this table, candidate, we have two quotation bases. One is the discount rate and the add-on rate. Now, in the context of money markets, the add-on rate, the AOR, the add-on rate, typically refers to an additional interest rate or a markup that is applied to a base rate in order to determine the total interest that is charged or earned on the securities or on short-term loans, or it could be deposits, it could be this repo, and so on. So that's the meaning of the bond equivalent yield and the add-on rate. So let us now move on to determine the bond equivalent yield for instrument A, instrument B, instrument C, and instrument D. First, put down the formula is equal to year divide days times future value minus present value of the bond divide the present value of the bond. That's the formula. Bond equivalent yield is equal to year. We know a year has 365 days times over days. That is then we multiply this by the future value of the bond minus present value of the bond divided by the present value of the bond. So we then go to the question and check if we have all these inputs. All right. Now looking at the instrument A, because we are beginning with instrument A, the BEY for instrument A. BEY instrument A, the discount rate is the basis. Discount rate is the basis of instrument A. The quoted rate is 5.33%. We have the assumed number of days in the year. Assumed number of days in the year. The assumed number of days in the year is 360. We know a year has 365 days. So this input we have 365. divide by the days. The first sentence reads, below is the information on a 180-day money instrument. 180, so the days you have 180 days. Then we multiply by the future value of this bond. The future value of the bond is the par value. So you have the par value of 100 minus the present value, which we do not have, over the present value, which we do not have. So we are required to calculate the present value of this bond in order to determine the bond equivalent yield of instrument A. So when faced with such a question, candidates first of all put down the formula, then check from the question if you have all the inputs given in the question, just the way I've done it here. So you can see information given, we do not have the present value of this bond. So let us calculate the present value of this bond. What is the present value? Now the present value is given by multiplying the future value by 1 minus days over year times the DR, the discount rate, times the discount rate. Now the future value is 100 times 1 minus days. Now, when calculating the present value, candidates, we use the assumed number of days in the year. We are going to use the assumed number of days in the year. Assumed number of days in a year. So we have 180 over 360 for instrument 1 times the DR. The DR, the quoted rate is 5.33%. 5.33%. This is going to give us the future value for the first instrument. Future value for the first instrument. So I'm going to take my calculator and determine this future value. This is going to be, so I'm getting 97.335. That is the present value, which we come and insert here. 97.335 over 97.335. This is going to be the bond equivalent yield. So we multiply this by that. 5.552%. So 5.552% is the bond equivalent yield for instrument A. How about instrument B? The bond equivalent yield instrument B, we're going to use the same formula, year over days times the future value minus present value over present value. Why? Because the quotation basis is the discount rate. The quotation basis is the discount rate. The quotation basis is the discount rate. All right, do you understand? So you're going to have 365 divide 180 times the future value is the par value, 100, minus the present value, which we do not have, over present value, which we do not have. So I'm going to have another working here for the present value of bond for the bond equivalent yield, instrument B, the present value of instrument B. What is the present value of instrument B? Now, the present value of instrument B, we use the same formula, but what will change is the quoted rate. The quoted rate, this quoted rate, which is the discount rate of 5.36. 5.36. So it's going to be the same. The only difference here will be the quoted rate, this quoted rate. The quoted rate for instrument B is 5.36%. 5.36%. That is going to give us the present value of instrument 97.332. 97.36. 97.32 shillings. Now, we will come here, candidates, and plug in the 97.32 over 97.32. So you will multiply that to get the bond equivalent yield for instrument B. The bond equivalent yield for instrument B. 5.498%. That is the bond equivalent yield for instrument B. We move on to the bond equivalent yield for instrument C. The bond equivalent yield for instrument C, candidates, and the quotation basis for instrument C is the add-on rate. The add-on rate is the quotation basis, and therefore the formula is going to remain the same: year over days times future value minus present value minus the present value. This will be equal to 365 divide 180 times the future value. This is a future value, which in this case is not known, minus the present value. When using the add-on rate as the basis, the par value is the present value. The par value is the present value, and the par value is 100. It is the opposite when using the discount rate. So you can see we have the present value in this formula. What we do not have is the future value of this bond. I want you to note the difference, candidates, that when using the discount rate as a basis when calculating the bond equivalent yield, the par value is the future value. The par value is the future value. That's why the unknown is the present value, which we calculated. These are the unknowns in A and B, which we calculated. But when calculating the bond equivalent yield using the add-on rate as the basis, then the future value or the present value is the par value. The present value is the par value. This present value is the par value, which is 100. So the unknown in this calculation is the future value of this bond. The future value. We need to determine the future value of this bond in order to calculate the bond equivalent yield of instrument C. So what is the formula for calculating the future value when using add-on rate as the basis? The formula is as follows: present value plus we get the present value into days of a year times the add-on rate times the add-on rate. So this we are going to multiply and get the future value of the bond. The future value of the bond. Do you understand, candidates? This is how you go about it. The PV is the present value, which is the principal amount, or the price of the money market instrument, which is equal to 100. Which is equal to 100. The PV. This PV is 100 plus PV 100 times the days. Look at instrument C. Instrument C, we have the days. The assumed number of days is 360. Divide by 365 times the add-on rate for instrument C. The add-on rate for instrument C is 5.35%. 5.35%. That will give us the future value. That will give us the future value of this bond. So I have into 100 times days is 180, divide by the year. And candidates, when calculating the future value and the present value, the year here is not the 365, but the assumed number of days in the year. For instrument C is 360. Please note that when calculating the present value and the future value, we use the assumed number of days in the year. That's why in instrument B or B, we use the 360. All right. So in C, we are using the assumed number of days in the year is 360. So we use 360 times the add-on rate for instrument C, 5.35%. 5.35%. 5.35%. That is how to calculate the future value. That is how future value is calculated. Future value for instrument C. Future value for instrument C. And the answer there will be, this is that is the future value. That is the future value. Right? 675. Future value is, the future value here is 102.675, which will be equal to 5.424%. That is the bond equivalent yield for instrument C, 5.424%. 5.424%. Then lastly, we have the bond equivalent yield for instrument D. Now, instrument D, the quotation basis is the add-on rate. The assumed number of days in the year is 365, and the quoted rate is 5.45%. 0.45%. So the formula still remains 365 minus 180 times the future value. Because it is the add-on rate, we do not have the future value, minus the present value, which is 100, over the present value, which is 100. So we need to calculate the future value here of instrument D. Future value for instrument D will be equal to the present value, which is 100, plus into 100 times the number of days. The number of days is still 180 here. We divide by the assumed number of days from the question is 365. 365 times the quoted rate. The quoted rate is 5.45%. 5.45%. And these candidates we don't need to calculate, because if the assumed number of days, is 365, then automatically the answer that we are going to get here will be the quoted rate, which is 102.688. That is the future value of instrument D. The future value here of instrument D, 102.688. That will be equal to 5.45%. That is the bond equivalent yield, instrument D. Now, candidates, you must have noticed that the calculated bond equivalent yield, instrument D, is 5.45%, which is the same as the quoted rate. The quoted rate is 5.4. The calculated bond equivalent yield of 5.45% is the same as the quoted rate of 5.45%, and that is the case because in calculating the future value, that always has to be the case, because when calculating the future value of the instrument, we used the 365 days, which is the days in a year, as the assumed number of days in a year. So that is the answer to that part of the question. This is Roman 1. We've calculated the bond equivalent yield for each instrument. The bond equivalent yield for each instrument. For instrument A, the bond equivalent yield is 5.552%. Those are the workings plus the other workings there. The bond equivalent yield for instrument B, we got it. We see here it's 5.498%. For instrument C, the equivalent yield is 5.424%. Then lastly, the bond equivalent yield instrument D is 5.45%.